All right, welcome, boys and girls. This is the next lesson. This is lesson 6 of Unit 3, and we are talking about zeros. Zeros. Um, Let me kind of break down a simplistic idea for you. And here's your simplistic idea. Um, if I start off with a basic equation, let's say x to the third minus, no, let's not do that. Let's keep it more basic than that. X squared minus 5x plus 6. All right, and I want to know what are factors of this. And so ways that I can find factors is I can literally know how to factor this thing, so multiply and add. So I can multiply to 6 and add to 5, and I know that that would be -2 and -3. I could do it that way. Or I could take that original problem, 1, -5, and 6, and I can test it out with a specific number. So I'm going to test 2. So I synthetically divide. And if I get a 0, huzzah, that is a 0. All right, so this 2, which originally stems from x minus 2, is a quote-unquote factor, which you could do that, and the rest is left over, okay? And we'll talk about that more a little bit today. So we can factor with synthetic division, or if you just straight up know how to factor, then that's cool. All right, these things are called factors. Things that multiply to be back to the original problem. Now, if I take these pieces, so for instance, x minus 2, and I set this equal to 0, that would mean x is equal to +2, or x minus 3 is equal to 0, and that comes out to be +3. These things are called zeros. So if I were to take the number +2 and plug it back into the original equation, my answer would come out to be 0. Just like if I were to take the number 3 and plug it back into the original equation, my answer as well would be equal to 0. So these values that come off of these factors are called zeros. That's what we're really kind of after today with our problems here. So, the easiest way to start looking for zeros is to see if we can factor it relatively easy. And what I mean by factoring it relatively easy, I'm talking about, GCF, simple ABC, complex ABC, what are the grouping, difference of squares, or cubes, right? That's the first thing that you should look for. Is there a GCF, simple ABC, grouping, things like that. And if you can factor it that way, cool. But if all of these things fail, or these things don't break it down to where you have something very simple like x minus 2, you may need to use synthetic division. And so synthetic division will get you what you need. So if I'm able to, synthetically divide by a +2, and that remainder comes out to be 0, that implies that x minus 2 is a factor, and x is equal to 2 is a 0. Right? So you'll kind of see what I mean as we go along, and I'll try my darndest to hint you in on my thought process about what's going on here. All right, so here we go. Find all rational zeros of the function blah, blah, blah. And they give you some ideas about, hey, these might be the answer. All right? So, rational zeros. I do notice that I can GCF. I can take a 2 out. Okay, now that doesn't give me any zeros yet. It does give me a factor of 2. Okay, that's fine. All right, but it makes my equation just a little bit easier to deal with. And now what I'm going to do is I'm going to try some of these numbers. Okay, I'm going to try, see if I can get a 0 out of using some of these numbers, or factor it anyways. I think I remember this from the last assignment. I think 10 is a 0, or 10 is a factor. So I'm going to start there. So I'm going to synthetically divide with 10, because notice how grouping won't work right here. Grouping doesn't work. So I have 1, -7, -28, and -20, and I'm trying this out with +10. So I drop the 1, multiply, add, which is +3, +30, +2, +20, 0. Okay, so what that means is this. What this just told me is this. This problem of x to the third minus 7x squared minus 28x minus 20 just got a little bit more simple because I just did it with this +10, which means x minus 10 is a factor, and this result is also a factor. So because I got this +10, that means it's a factor, and also x squared plus 3x plus 2 is also a factor. So notice how the answer, the result, is also technically a factor. So this +10, aka x minus 10, is a factor, and the answer is also a factor. Okay, now what do I do? What I'm really trying to boil all of this down to is a singular big long multiplication with singular x's. So what I'm going to do now is I'm going to see, hey, can I break this polynomial down? And this is a simple ABC. I'm going to multiply to 2 and add to 3. So multiplying to 2, both positive, both negative, adding to 3 would be +1, +2. So this, I can simple ABC, which is +1, +2. All right? There's still this x minus 10, and still this outside 2. All right, so all of these are quote-unquote factors. This question is asking for what are the zeros of this. All right, so I'm going to get an answer for every single one of the x's that I have. So I have 1, 2, 3 x's. That means I'm going to get 3 answers. This first x minus 10 is going to be +10. This next x is going to be -1. This last x is going to be -2. So the zeros that I have are +10, -1, and -2. Those are the zeros. So the factors are the things that multiply, and the zeros are the resulting things that you get back out of it. Okay. This problem right here. I see that I can GCF. So I can take out an x, which turns this into an x to the fourth minus 3x squared plus 54. Okay. You might think that this is a simple ABC, but it's not, because the simple ABC relies upon an x. Oh, I can simple ABC this. My bad. I can simple ABC. 54. It's 1, 54, 2, 27, 3, 1, 8, 4, no, 5, no, 6, 9. Both positive or both negative. It doesn't work out very well. Okay, so because I'm trying to get to a positive 54, these are my results. I could get a 154, 227, 318, 69, negative 1, etc. I can get these results. And, but I have to add to a negative 3. None of these add to a negative 3. None of these add to a negative 3. Like, nothing even comes close. All right, so when I can't factor, no matter, no way, no how, all right, when I can't factor, then I think all is lost. But I'm sorry that I'm stammering, because I'm almost positive of my answer here, but let me just bring up a graph real quick. So I have an x to the fourth minus 3x squared plus 54. Yeah, and that is going up, and it never touches a 0. Okay, so good. All right, that's exactly what I thought. All right, so this is not factorable. Okay, that's not factorable. I can't factor. So even though you may want to, x to the fourth minus 3x squared plus 54 doesn't break down to anything nice. However, I was able to draw out this x. So I am able to get an answer to that x. Outside x's are equal to 0. So the only rational 0 in this situation is x is equal to 0. Again, these are factors. These are zeros. Okay, so I could get answers to these things, but they're not quote unquote rational zeros. They're all like, they would be like imaginary numbers and stuff like that. So, all right, here we go. Hopefully the rest are a little bit nicer. Okay, find all the rational zeros of this. Okay, so I'm going to first start off with something easy, and let's start with -1. I'm going to see if -1 is a 0. Start off something easy. Hooray! Got a remainder of 0. that means -1 is a 0. And what that also means is x plus 1 is a factor. Okay. Now, looking at what I have here, I'm thinking that this might be a complex ABC. All right, so complex ABC means I multiply the first and the last number, and that's my multiplication number. Going to a positive 15, what do you know? Write the first term as a fraction twice. So this is going to be 2x positive 5 and x positive 5 with the x plus 1. All right, these are all quote-unquote factors. Okay, these are all factors. The zeros are the answers that you get off of this. So this would be -1. This one would be -5. Okay, what about this x that's in the middle though? If you recall my old statement, it's opposite number over letter. Opposite number over letter, so the number is 5, the letter is 2. So it's -5 over 2, so opposite number over letter. Or if you don't feel comfortable with that, what you can do is you can take any one of these pieces, like so for instance, x plus 1, and you can set it equal to 0, and you can just do some basic math. So -1, x is equal to -1. It is. Or that last one, x plus 5, set it equal to 0. So here I -5. And that leaves me with x is equal to -5, which again, it is. So that middle one, I can set 2x plus 5 equal to 0. And again, just do some basic math. -5. So that leaves me with 2x is equal to -5. Divide by 2. X is equal to -5 over 2, which it is, again. So if push comes to shove, you can just set the piece equal to 0. Or if you remember, my statement is opposite number over letter. Opposite number over letter. Opposite number over letter. Right? And again, what these are the zeros. So factors can be created into zeros. Factors give you zeros. All right, find all the rational zeros. All right, let's try. I think 3 might work out. 3. Let's try 3. So I have values of 1, -1, -21, and 45. So I'm going to try the value of 3. Now, if this comes out to be a remainder of 0, that means x minus 3 is a factor, and x is equal to 3 is a 0. Again, if this comes out with a remainder of 0, that lets me know those two things. That would let me know that a factor is x minus 3, and a 0 would be positive 3. But let's check it out. I don't know if this is true or not. Let's see what the math says. So drop, multiply, add, multiply, add, multiply, what do you know? Add. So it did come out to 0. So as I said, what I know is x minus 3 is a factor, and x is equal to positive 3 is a 0. Okay, that's what I do know from this, stemming from this mathematics right now. All right, so what just happened is this. X minus 3 is a factor. And then so is the answer, which is x squared plus 2x minus 15. That is also technically a factor. So what I'm going to do now is I'm going to check this one out. This one looks like a simple ABC. And I'm going to see if I can factor that. Simple ABC. So I see that the multiplication number is negative 15. So 1, 15, 3, 5. One number is negative or the other. Trying to add to a positive 2. There it is. All right, so x minus 3 and x plus 5 are factors, but so is this already, this outside minus 3. All right, so that is factored completely. That is factored completely. But the question is, what are the rational zeros? So every single one of the x's, so the rational zeros are positive 3, and negative 5. So obviously there's a repeat on the positive 3's, so you only have to report it once. So the rational zeros are 3 and negative 5. Again, just to make sure you know the vocabulary, these things are called factors. Okay, these are called zeros. Because I was able to divide and get to a 0, that means x minus 3 is a factor. Because that answer was 0, x minus 3 is a factor, and x is equal to positive 3 is a 0. That's what that told me right there. Because the remainder was 0. That's really ultimately what they're looking for. Okay, let's find all the zeros. Let's try positive 2. Let's try positive 2. So again, if this answer is 0, that means x minus 2 is a factor, and x is equal to positive 2 is a 0. If the remainder is 0. If not, then we got to try again. So here we go. 1, 2, negative 5, negative 10, negative 8, negative 16, and then the 24. Nope. So nope, neither one of those things are true. Okay, the answer did not work out in our favor. Let's try something a little bit bigger. Let's try positive 4. Okay, let's try positive 4. Hooray! Positive 4 did work out. So because of that, I know that x minus 4 is a factor. Okay, and then ultimately x positive 4 is a 0. But let's start with that factor. Because I know what one of the factors is, that means that f of x, this equation, is now x minus 4, and the answer, which is x squared minus 3x minus 10. Now I can look at this as a simple ABC. Multiply to negative 10 while adding to negative 3. So that would be positive 2 and negative 5. Those numbers multiply to negative 2, but yet add to negative 3. There's an x minus 4 still attached. So I have singular x's, so these are all the factors. And then all the zeros would be x is equal to positive 4, negative 2, and positive 5. All right, trying to make this a little bit more difficult than what it has to be. What I see is that there's a GCF in this next problem, so I can take a 6 out. Doesn't get you any zeros. There's no x's on that 6, so you're not going to get any zeros, but the numbers are a little bit easier. All right, so let's take a number like 2 or something. Let's try 2. So I have 1, -4, -7, and +10. All right, so 2 didn't work. Let's try try 5. Let's try 5. Aha! 5 worked. Okay, because 5 worked, that means x minus 5 is a factor. The answer is x squared plus 1x minus 2 is a factor, and then that 6 that I originally took out. All right, now I can simple ABC this last parentheses. I want to multiply to -2 and add to +1. So that's a -1, +2. So those two numbers multiply to -2, but yet simultaneously add to a +1. It's an x minus 5 and a 6. All right, so these are all the factors. The zeros are all the answers to the x's. If it doesn't have an x, it doesn't have an answer. All right, so x is equal to, there's an x, there's an x, and there's an x. Right, the 6 doesn't get any answers. There's no x's there. Right, so this would be +5, +1, and -2. All right, here we go. I think you kind of get the idea of it by now. Let's try 3. Try 3. So I have 1, 2, -11, -12, and I'm going to try 3. +4, +12, 0. Man, I'm getting better at this. All right, so that's awesome. That's awesome. So 3 worked. So that means my equation is now x minus 3, and the answer is also, so x squared plus 5x plus 4. So here I want to multiply to 4 and add to 5. So that's 1 and 4. +1, +4. They multiply to a +4, but yet add to a +5. There's this x minus 3 that got the party started. Everything is a singular x. So again, these are all factors. And then the zeros, which that's what the question is asking for, is going to be +3, -1, and -4. All right, I'll kind of explain some of my theory here in just a second. Right here, I can see that I can take out an x. I can GCF out an x. So ultimately, this 0 is going to be equal to 0. Outside x's are equal to 0. All Outside x's are equal to 0. Anyways, this is x to the third, 14x squared, 51x plus 54. Now, when I set this up for a synthetic division, I need numbers to get smaller, not bigger, really, in essence, to cancel things out. I need some of these answers to come to a negative. Now, when I see that all of these numbers are positive, that means I need to interject a negative number somewhere in there so something will subtract. So I'm going to be thinking that their outside is going to be a minus of some sort. So when I'm going to just start guessing numbers here, I'm going to guess a negative number. I'm going to guess a negative number. So let's guess negative. Let's try just something simple, negative 2. So I have 1, 14, 51, and 54, and I'm going to try negative 2. Oh, positive 17, I'm sorry, positive 17. And that's negative, wow, negative 54, all right. So perfect, because I did need something to subtract, and the only way to get a minus in there, a negative, is if I put in the negative, so I did. So what that means is x plus 2 is a factor. X plus 2 is a factor, and that leaves me with x squared, 12x, 17. All right, now, the result would be a simple ABC. Like if I were to guess what this is a simple ABC. But that would mean that I would have to multiply to a positive 17. The only way to multiply to a positive 17 is 1 and 17, whether it be positive or negative. Now, notice that these things don't add to 12. So what that means is I'm not able to factor this thing. I can't break that down any more. So that means I'm not going to get any zeros. That implies that there's no rational zeros. Okay? It's not factorable. I'm not going to get any rational zeros. So what I have right now is as good as I can get. So these are, all of them are technically factors. So x is a factor, x plus 2 is a factor, and that is also still a factor. It's just I can't break that last factor down anymore. So those are factors. The zeros are going to be 0 and negative 2. Those are the only two rational zeros that I can get out. I can't get any quote-unquote rational zeros out of that last one. All right, let's get crazy and let's go with the 10/3. Let's go with 10/3 on this one. Wait, oh, let's not. Let's not. Let's go with 5. This is way too big. Too large, too large, too large. Sorry. 7. Way too large. Doesn't work. Let's try something smaller. Let's try the number 1. Nope, that didn't work either. Let's try -1. There we go. All right. Broke the ice. All right, there it is. Got our first one. Thank goodness. All right, so -1, so that implies that x plus 1 is a factor, leaving me with 3x squared, 5x, -50. This is going to get answers. I just don't know what they are right now. This is a complex ABC. So let me give myself just a little bit more working room here. And let's complex ABC this thing. And I would assume that a 10/3 is going to come off of this, but let's see. Okay, so complex ABC, I'm multiplying 3 with -50 is -150. I think that's the extent of it. I could be wrong somewhere along the line, but I see what the answer is going to be right now. Okay, because it's negative, one of the numbers is negative or the other one is. I'm adding to a +5, so there's my +5 right there. And so my result is going to be the front number, which is a 3x, a -10, and a 15. The second one simplifies. And so my result is a 3x -10, and then x plus 5, then x plus 1, as such. All right. So those are all the factors. Okay, those are all the factors. So the zeros are equal to -1. Opposite number over letters, so that'd be +10/3 and -5. And all this got started just by identifying 1. All you do is identify 1, and your problem gets easier. You don't have to guess anymore. Okay, last but not least, here I can take out, what, a 2? Oh, this is grouping. I see some grouping. I see some grouping. Grouping. So here I can take out an x squared. Here I can take out a -1. See how the insides are the same? So that's an x squared minus 1, x plus 2. Okay, and then there's this outside 2 that I originally took. Okay, and then this is square minus in the middle. So that is x plus 1, x minus 1. So I didn't have to use any synthetic division. My factoring skills are up to speed. Okay, so my factoring skills are good to go. So this is -1, +1, and -2. Those are the zeros. And these are the factors. All right. Now, if you didn't see that, or your factoring skills just, you're not as quick on the uptake as you would maybe like to be, this is absolutely doable with the methods that we have been doing. Okay, say you didn't see this stuff, you didn't see it. Okay, it's understandable. You didn't see it. That's fine. All right. So what you can do is this. I'm going to start guessing a number, and I'm going to guess one of the answers that I know. I'm going to guess that 1 is a factor. And so what you can do is you can try it out. I'm going to see, is 1 a factor? Or -1 a factor. So this would be 2, 2, 6, 6, 4, 4, 0. Hooray! That is a factor. So what I'm left with is x minus 1, 2x plus 2x squared plus 6x plus 4. All right. Let's just say I don't see the answers coming from that. So let's guess another one. Let's guess another one. So with this answer, I'm going to guess -1. So with this answer, again, I made my answer easier. Let's try -1. So that would be -2, +4, -4, 0. Hooray. And again, you don't include that very last one. So what that let me know is, okay, x minus 1 was now I know x plus 1 is also a factor, leaving me with 2x plus 4. Okay, so these are all technically factors. You get, like, in case your factoring skills aren't really up to speed, that's cool. So this answer is +1, -1, and this would be opposite number over letter. So -4 over 2 is -2. Hopefully that you can see, you can take a 2 out of this. Let's leave that. That's the idea.